Okie dokie, Smokies, here we go. For the following parametric equations, write an equation in x and y that represents this set of points. Okay, so basically what we need to do is get rid of the t's. The t is the parameter in these parametric equations, and we need to get rid of them. So let's look at it carefully. How might we get rid of the t's? Let's solve for t up here. We can't really eliminate in this problem because we got that crazy squared in there. But what if we took that top equation and subtracted 3 and divided it by 2? Right? Then we can take that guy right there and plug him in right here. So y equals x minus 3 over 2 squared plus 4 x minus 3 over 2. This is kind of a mess. Let's clean it up a little bit. Be careful, don't make that very bad mistake here. This is a FOIL. This is a FOIL. So it's going to be over 4. X squared minus 6x plus 9 plus, actually the 2's are going to cancel here, so 2x minus 6. Could I clean that up at all? Is there anything I could do to that to clean that up at all? I mean, we don't normally see equations that look like that. What could I do?
Back to the top and make it x minus 3 squared.
Well, that would bring me right back to where I was here. How about if we get a common denominator so we can add all this together? Can't we get a common denominator and add the whole shebang together? So if we want this to be over 4, we'll have to turn that into an 8x. And if we want this to be over 4, we'll have to turn it into a 24. Getting a common denominator. So now we have x squared plus 2x minus 15 over 4. Which is 1/4 x squared plus 1/2 x minus 15/4. Make sure that's right. 1/4 x squared, 1/2 x minus 15/4. Perfect. Now there's a lot of arithmetic there. There's no precalculus in that. None. Not anything in this problem is precal. We substituted, that's algebra 1, and then we just multiplied and got common denominators and did all that. Now we got to talk about domain and range. So let's get our calculators out and let's graph this picture. So 1/4 x squared plus 1/2 x minus 15/4. What window should I have? Probably standard. I'll just start with a Zoom 6 standard window. What shape did you get? Did you expect that? Yes. Why did we expect it? It's x squared. And what do x squareds always look like? BFFs. X squareds are parabolas. So I knew it was going to be a parabola. What I am curious about is, what is its domain and range? Now, the domain, I know. What's the domain? All real numbers. So negative infinity to infinity is the domain. What do I need to know to get my range, though? The minimum? Don't I need to know the minimum? So I'm going to go ahead and second calc minimum. And I want to find the low point, or what we call the vertex of that little parabola. I got, -4. So what is my range then? It's a parabola opening up, and this is -4 down here. So how do I write that? -4 to infinity, and this actually needs to be a bracket. All right, now, I'm just doing the first one there because I want to get through some more problems here, and it just took a while. Well, let's go to number 2. Is this relation, now we have graphed it, we've graphed it. Is this relation 1 to 1? Okay, who remembers what that means? 1 to 1. No one. Okay. If a function is 1 to 1, then that means no x's repeat in the problem and no y's repeat in the problem. In other words, 1x, 1y, 1x, 1y, no repeats anywhere. So, does this pass the vertical line test?
Yes.
Yes. That tells me no x's are repeated. So that's all good. Does it pass the horizontal line test? No. That tells me that y's are repeated. Doesn't this point and this point have the same y coordinate? Yes. So is the function 1 to 1? No, because it doesn't pass the horizontal line test. And to be 1 to 1, you have to pass both. Think of a BFF that's 1 to 1. What's a BFF that's 1 to 1? Linear. Absolutely. Because when you graph a linear equation, doesn't it pass vertical and horizontal? There are others, but that's a good one. This is not 1 to 1. Your graph clearly tells you that. All right, number 3, find the domain of the following, find the inverse, then find the domain of the inverse. Okay, we can do that. So I'm not going to do all these, but let's do a couple of them here. All right, let's look at A. Y equals the square root of x plus 1. Now I could put that one in my calculator, but before I do that, I think I can just sketch this one based on my knowledge. What does a square root function look like? Yeah, and this one's been moved which way? To the left. So I know this picture looks like this. Would everybody agree with that? This is the original function. What is the domain of the original function? -1 to infinity, right? What is the range of the original function? That picture right there, what is the range? 0 to infinity, perfect. Okay? Now, let's find the inverse. So what do we do when we go to find the inverse? What do we do? Switch the variables, so x equals the square root of y plus 1. Now I gotta get y by itself, so I guess I'm gonna have to square and subtract 1. so y equals, or f inverse equals x squared minus 1. Now this is a harder problem than you think, because if I said to you, graph that, you could. What's that? A parabola. But it's been moved down 1. So it would look like this, right? But I have to be careful, because this is the inverse of this, which means these ordered pairs just got flipped around. Isn't there too much in that picture? There's too much in that picture. All of the y's are positive. Would you agree with that? And all of the, oh, not quite, but almost all the x's are positive. When I did my inverse, I have to flip-flop. So the domain of this one has to be the range of the original. Remember, you switched the x's and y's. So don't these two, these are the x's and these are the y's of the original. Those become the x's and y's of the inverse, only they switch. So my range is -1 to infinity, and my domain is 0 to infinity for the inverse, which means I'm not looking at the whole picture, I'm only looking at that half of it. Sure?
Is that always gonna work or just for
Always
like
gonna work. Always gonna work. Now, most of the functions that we looked at before, the domain and range were all real numbers, and so then it doesn't matter because it's everything anyway. But when you have a restriction, you have some kind of weird shape like this, you have a restriction on your domain and range, then you're going to have a restriction on the domain and range of the inverse also, because they flip-flop, okay? So that's a tough one. Let's do an easy one, and then we'll do another tough one. So let's do B, because B is easy. What is the domain and range of this? Well, what shape is that? A line. So if it's a line, its domain and range are everything, right? Think about what a line looks like. Now, these are going to become the domain and range of the inverse. So we're not going to have any funkiness happening. Let's just find the inverse. So how do we do that again? We switch the x and the y. And then we get y by itself. I got that. Did I do that right? Now, isn't this another line? It looks a little different, but isn't that the same as 1/2 x plus 1 if you wanted to do it that way? What's the domain and range of that? Oreos. Yeah. So if it's a line, it's as easy as it can possibly be. It's when you've got these other weird shapes that it's a problem. So let's do C. So start at the beginning. What is the domain and range of C? All right, look at it carefully. This guy has asymptotes. Where is the vertical asymptote? At 5? So your domain is everything except 5. If you have an asymptote at 5, then that means you can't be 5. So you're everything up to there and everything past there. So that's the domain of the original. Does this one have a horizontal asymptote? It does. Where is it? 1. If you are an asymptote, you cannot be. So your range is everything except 1. Because y can't be 1. That's your asymptote. Remember that whole trick right there? That's your asymptote. Now, I don't know what my inverse is yet. I haven't found it yet. But I can tell you the domain and range of the inverse. What's the domain of the inverse? Everything except 1. And my range is everything except 5. Now we're going to find the inverse, but I've already answered the domain question. Because the domain of the inverse is the range of the original. Every time. Every time, no matter what. Okay, so what does the inverse look like? Well, how do we find an inverse? What are our steps we go through? We switch x and y. All of the x's, all of the y's. Now what? You gotta get y by itself. So we're gonna multiply this over to here. We had some of these in our notes, guys, or at least one in our notes like this. So we're gonna move the y minus 5 over to the other side. Now what? Distribute. Actually, no, I'm not gonna subtract 1, I'm gonna distribute. If I have to get y by itself, then I need to have the y's on the same side so I can factor them out. So now I'm going to switch these two, move this y over to here, and move the 5x over to here. Now look at that carefully, guys. We did this. Oh my goodness. Bring this over to this side. Distribute. Now we want the y's on the same side. Once you get them on the same side, factor them out and divide by the parentheses. So there's your inverse. Now, does that jive with what we thought was going to happen? Is my domain everything except 1? Just like I thought? Yeah, because my asymptote's at 1. Is my horizontal asymptote at 5? Yep, see how that works? You need to know how to do that. You need to review those steps. Make sure you have those steps down and make sure you can go through that on your own. GTQ, guaranteed test question. All right, we can come back and do some more of those, but let's get it in a full set of problems here. Number 4. Prove. That is the key word there, boys and girls. Prove that these are inverses. So the functions are 4 plus 5/3 n and 3/5 n minus 12/5. All right, your job is to prove that these are inverses. There's only one way to do that. Does anybody remember what it is? Lauren?
Don't you substitute Gn into Fn and then the other way around?
Exactly. So in other words, you build the composition f of g and g of f, and both of them have to come out to equal, in this case, n. Usually it's x, but on this paper it's n. Okay? So we're going to build the composition. So this says plug g into f. So take this and plug it in here. So that'll be 4 plus 5/3 times 3/5 n minus 12/5. So we're doing a composition. We are plugging the g function in for the n in f. We're gonna work all that out. Then we're gonna plug the f function in for the n and g, and work all that out. Let's do one at a time. Alright, so what does this come out to be? 4 plus, alright, let's distribute. What happens here? Don't you just get n? And then distribute. What happens when you multiply 5/3 times 12/5? 4. And that's exactly what needed to happen. If they are inverses, everything's going to cancel out and you do with just your variable. So now we do the other one. You have to do both. This is the only way to do this problem. Plug G into F, and then plug F into G. So I took the F function and plugged it in here. Alright, so let's distribute. What's 3/5 times 4 over 1? 12 over 5. Plus, what's 3/5 times 5/3? Did that one work out?
Yeah.
It sure did. If anything else happens, so let's say you got n plus 1, then they aren't inverses. They're only inverses if everything cancels out and you're left with just plain n or x or a, whatever one you do. Now, that is a different question than number 4. This is the proof. Could you do number 5 the same way? Yes, you absolutely could. So if you are comfortable with that, you could do number 5 the same way. But since 5 isn't a proof, it's a little bit more flexible. Another way that you could do number 5 is, Jada, what's your football number? 75. That's kind of a big number, but I think we can do it. So another way that you can do this problem is take a number, like I'm doing 75, and plug it into function f. What do you get if you plug 75 into function f? 149. Now, take the 149 and plug it into function g. Well, what happens when you put 149 into function g? You get 75 back again. Those are inverses. Can you see? 75, comma 149, and 149, comma 75. This is the x, f of x, this is your x, and this is your y. So this ordered pair for the original function was 75, 149. An ordered pair for g is 149, 75. That shows their inverses because what do inverses do? Switch x and y. That is not a proof. So you can't do this for problem 4. But when you're just showing things are inverses, you're showing this general relationship. Okay?
Would you, be able to just take the equation and then solve for the inverses?
And solve for what?
Like the inverse?
Oh, find the inverse of each one?
Yeah.
Absolutely. That would be another way to do it. Yep.
Just put in
Any number. Any number. Now, I would stay away, Brayden, from zeros and ones, because those are special numbers, but any other random number, absolutely. What I want you to know is recognize this, if these guys are inverses, their ordered pairs are switched. So if I tell you that f of 5 is 7, and then I say, what's f inverse of 7? You will say 5. They are switched every time if they are inverses. Okay? All right, that's 4 and 5. Okay, 6. A circle is inscribed in a square side S. Write the area of the circle as a function of S. All right, this sounds way, way, way harder than it is. A circle is inscribed in a square. Inscribed means it just fits perfectly in there. There's no edge to edge, it's perfect. The side of the square is S, it tells you that. You are gonna write the area of the circle. What's the formula for the area of a circle? Pi r squared. So would you agree that that's a radius? And isn't this also a radius? So the side is 2 times the radius? Would you agree with that? In this situation? So R is S over 2? So the area is pi times S over 2 squared, which is pi S squared over 4. There was nothing wrong with this formula right here, except it was in terms of R. And the question said, do it in terms of S. So we had to figure out what the relationship was between S and R, and then we could substitute that in, and now it's in terms of S. All right? Describe the transformations to go from this to this. Now, you can do this however you want. You know what this looks like. What shape is this? That's a parabola, and it's a parabola that's been shifted left 2 and down 8. So it's left 2 and down 8. Would everybody agree with that? Now we want to move it so that it's where? Right 3 and down 4. So you need to just talk about how you're going to move it. If it's got to go from -2 to 3, then you're going to have to take it right 5. So it says, describe the transformations. You're going to move it right 5 units. And then what are you going to do? Up 4 units. I think with a picture it makes it really easy to figure that out. Now, what if there'd been a negative, not like out in front of this one? Then what else would have to happen? Well, first of all, it wouldn't look like that, then it would look like this, right? So what else would you have to write? Turn it upside down. Because that's what a negative out here does, right? Is turn it upside down. What if we've thrown a number out here in front like a 2? What does that do? Makes it twice as tall. So in terms of the parabola, you're not drawing this, you can if you want, but you're not part of, that's not part of the grade, but in terms of the parabola, if you're making it twice as tall, you're stretching it, so it's gonna become skinnier, right? All right, so you got that, okay? All right, let's look at a couple problems on the back here. David earns $2,000 a month, his rent is $450. What percent, oh, this is easy. What percent of his salary is his rent? What am I typing on my calculator? Don't make it hard. What would you do? 450 divided by 2,000? Isn't it 22.5% of his salary? Just divide. Will someone like nod? That's easy, right? Everybody's got 22.5? Okay. How many ounces of 5% lemonade? I have to use this setup to keep it all straight. There's a lot of numbers in this problem, so I kind of keep it all organized this way. So how many ounces of 5%? And remember, 5% is 0.05. Need to be mixed with 8 ounces of 12% to get a mixture that is 8%. Does that make sense to you so far? I gotta come up with something to put in this blank right here. What do you think that's going to be? Meg? X plus A, or I think of A plus X, that's exactly right. Because this amount plus this amount has to add up to this amount. So if I dumped in X with this picture and 8 with this picture, then I'm gonna have 8 plus X. Now we just work it out like a regular equation. Check my arithmetic. It's so embarrassing, but it's not very good. This is a distributive. Don't forget your distributive over there. Got it? Most important part is getting the setup right, because I'm pretty convinced if you can get the setup right, that you'll get the rest of it right. All right, let's do some graphs. We don't have time to do all these because I want to get to the box problem, but whoops, we don't have a graph on there, so let's make one up. All right, draw this. This is going to be our main graph. So over 2, up 2, and then we'll come over 1 and down 1. So that's our main graph. So graph that as your function. Sorry about that. And then look at those 5 problems. Let's do a couple of them. So which ones would you like to do? B, C, D, E, or F? Which one?
D.
D as in dog?
Yes.
All right, D as in dog. says sketch f of 2x. All right, now what we gotta remember, kids, is what does a 2 coefficient multiplier inside the parentheses do? Who remembers? What does that do, Lauren?
Divide the width.
Divides the width. That divides the width. So in other words, my original triangle, the big triangle, the right side triangle, was 4 blocks wide and 2 blocks tall. So the new one is going to be still 2 blocks tall, but now it's only 2 blocks wide. And the short little triangle was 2 blocks wide and 1 block tall. So now it's still 1 block tall, but it's only 1 block wide. So all of the x's, the width, the x's, got divided by 2. All right, let's do another one. What's another one, Mary? E. Now, E has 2 things happening. What are the 2 things happening in E? Sideways flip, or however, you have different ways of thinking about that. Sideways flip is one way, reflect across the y-axis, change the sign on x, whatever works for you. And then what does this guy do? Up 1. So we're going to take our picture, I'm going to do it in 2 steps, you can do it more if you want. We're going to take our picture and we're going to sideways flip it. So what that means is, instead of drawing the bigger triangle on the right, I'm going to draw the bigger triangle on the left. I am not changing it in any way, I am simply drawing it on the left side of the graph. And then the little triangle is going to be drawn on the right side of the graph. That is a sideways flip. Now I'm going to take every point and move it up 1. And on your grid, that's easy. Just point by point, up 1. Up 1 box. And the blue is the answer to the question. Okay? Now let's look at our box problem and then we can do whatever in our remaining time. So let's look at our box. Okay. All right, so what do we have to do? We got a piece of paper. It says draw a picture. Okay, that's just gonna look like this. How big is the paper? 12 by 18. Pull it up the flaps. All right, here we go. Express the volume of the box as a function of x. Okay, who can do this? Easy, easy. What's this equation look like? Well, it's length times width times height, but we got to do it in terms of x. So what's our length of this particular piece of paper, or this particular box? 18 minus 2x. And what's the width? 12 minus 2x. And the height is x. So when it says, and again, this is fancy math talk, express the volume of the box as a function of the width of the squares. Okay, there it is. That's the volume of the box in terms of x. Now what's the domain of this function? You're going to write it as an interval, but what you're really telling me is whatever x is, it has to be between these two numbers. What two numbers are we talking about? Gotta be bigger than 0. I mean, obviously, you can't cut negative, so it's bigger than 0, but less than 6. So, when I go to my calculator, which is next, this is gonna be x min, this is gonna be x max. Y min is gonna be 0 because y is the volume, and the volume can't be negative. And then Y max is your guess. You're just gonna put a number in, like 100 or 200 or 500. And you'll make adjustments because ultimately, when you press graph, don't you need to see something that looks like this? All right, so let's do it. Window, 0 to 6, 0 to, now let's try 300. Don't forget this X. We had some problems with some of the kids this morning forgetting that X. Don't forget that X. I used Y max at 300 and that worked out great. So then the second calc max. Left bound, set it over here somewhere. Left side of the mountain. Go to the right side of the mountain. Go to the top of the mountain. And my ordered pair, tell me if this is what you got, 2.35, comma 228.16. Everybody catch up, make sure everybody's getting those numbers. Those sound about right. So now we're going to answer the two questions. The first question is, what is the maximum volume? Okay, what is the maximum volume? 228.16 cubic inches. That is the answer to question C. Now question D says, what if I wanted my volume to be 150? Now, 2.35 inches will create this volume, correct? So there is another X number that will make the volume 150. Now, on your graph, this is 228 right here. Isn't 150 then down here somewhere? This point and this point are where the volume equals 150. So now we're going to go back to y equals, leave that equation in, but for your second equation for y2, type 150 and hit graph. Do you see this exact picture? Now, how do I find this point? I do it just like I did before, only I don't look for maximum, I look for intersect. So second calc intersect. Set the cursor down here somewhere, so on the left side of this point, press enter. Now it's on the line, so press it over here. And I got that point to be 0.91, comma 150. Now you find this one. Do exactly the same thing to find that one. So start over again. Second calc intersect. First curve is on the left side, second curve is on the right side. It's just like left bound, right bound, only it doesn't say that. Anybody get this one? 4.14, comma 150. So what's the answer to the question? How big should the cutouts be for me to get a box with a volume of 150? Well, they can either be 0.91 inches, or they can be 4.14 inches. Would you agree with that? Okay, tomorrow we have class again. You have a multitude of review materials. I want you to look through it. We can do problems